Lesson 6.3, Day 2, still working on writing, solving, and graphing compound inequalities and modeling real-life situations using compound inequalities. As a quick review, a compound inequality consists of two inequalities connected by either the word and or. Yesterday we looked at the and compounds. Today we're going to look at the or compounds. The solution of an or compound inequality needs to only be true for one of the inequality statements. Versus yesterday with the and statement, it needed to be true for both. With an or statement, it only needs to be true for one of your inequalities. All right, now we're going to translate the inequality from the written word to a statement, starting with x is less than 4 or x is greater than or equal to 5. You have two independent statements here. Starting with x is less than 4, let's translate that one. So x, our less than symbol, and the negative 4. Over here on the right side, our second statement is x is greater than or equal to 5. So when we translate this one, we get x, our greater than symbol, with the or equal to part on the bottom, and 5. And as part of writing this statement, it is important that you remember to put the word or in between. Okay, on this next slide, we're going to sketch the graph given the two inequality statements. So again, let's start with our first one over here on the left side, which is x is less than or equal to negative 2. So I'm going to start with the negative 2 on the graph. Because it is an or equal to inequality, I'm going to need to put a solid dot, and then to graph the rest of the solutions, being less than would be to the, let's try this again. There we go, to the left on the number line. Our second inequality statement, x is greater than 4, would be an open dot on the 4, and then our solutions being greater would be to the right. Okay, now just to show you the difference between an and an or statement. With your and statement, the solution had to be true for both of your inequality statements. However, with the or statement, it has to be true for one or the other. So for instance, on this side, let's take negative 6. If I put negative 6 into my first inequality, I still have a true statement. Therefore, all the solutions to the left of my point negative 2 are valid because they are all less than negative 2. Over here, if I pick a point on my right-hand side, such as 7, 7 is greater than 4, which is also a true statement. And again, every point to the right of my 4 would be true in my second inequality. However, if I selected something like 1 in the middle, 1 less than or equal to negative 2 does not work. Or 1 is greater than 4 does not work either. So all of the points in between do not work for one or the other. Okay, now we're going to do just the reverse. We're going to take it from the graph and write the compound inequality statement. Starting with the left side, over here at negative 2 is where we have the first inequality on the graph. Our x values are less than, and because it is a solid dot, or equal to the negative 2. Over here on the right side, we're going to start with x is, and here again we have greater than or equal to the positive 2. Please remember with an or statement, it is important that you write the word or in between. On to solving the inequalities and then graphing the solution. Starting over here on the left-hand side, we need to isolate our x variable, so we'll divide by the negative 3. Please keep in mind that with the inequalities, whenever you divide by a negative, you must reverse your inequality symbol. So over here, I would get x is greater than or equal to negative 5. Our second inequality over here, the only inverse we have is to subtract the 5 to isolate the x. So x is less than negative 6. Keep in mind we are talking about an or statement, please. So our first solution on the graph would be a solid dot at negative 5 with the solutions of greater than going to the right. And our second inequality would be an open dot at -6 with the solutions less than. Therefore, we would highlight all of the values less than -6. Okay. All right. On this last slide, we just have multi-step problems. Starting with a two-step, our first inverse would be to subtract 1 from both sides, bringing down the 2x, and now we have 12 over here, finishing out by dividing by 2. Since I divided by a positive, the inequality symbol remains the same. So the solution on my first statement is x is greater than 6. Over here on the second side, my first inverse would be to subtract the 3, leaving me -21 and 7x. Again, dividing by the coefficient of 7 to isolate the variable, leaving the inequality symbol the same. So I actually have -3 is greater than x, or for those of you who prefer to put the variable first, it would be x is, remember to reverse the inequality, -3. Again, this is an or statement. Make sure you write that in your final answer. Going on to the graph now. Our first inequality says x is greater than 6, so that would be an open dot at 6 with the solutions to the right for greater than. And our second inequality is x is less than -3, again an open dot at -3, and less would be to the left. Okay, that takes care of the or statements. Please remember, if you have any questions, to ask your teacher during class, and also to forewarn you, on Monday we will be combining the ands and or statements in class.